This morning, we've got two gentlemen from KraftPowercon who are going to be talking to us about the high voltage products and the solutions that they have for electrostatic precipitators around the world. And before we begin, I'd like to have each of them give us a little bit of introduction on themselves, and then we'll get a little introduction on the company. Paul, would you like to start out and introduce yourself?
Yes, my name's Paul Leanza. I'm the business development manager for all the Americas for Kraft Powercon that makes high voltage precipitator power supplies. I've been in the electrostatic precipitator industry since college, 1989, 88. So I'm familiar with these products and how they're applied.
My name's Dan Holt. I'm a paper mill guy, so after college I went to work in a paper mill. I learned about precipitators and boilers, and it took a while, but learned about facing the everyday issues with these devices, and just glad to be here and helping customers go around making these things work for people and making them function and do for the atmosphere what they're supposed to do and keep production going.
Well, a pulp mill is a good place to learn about precipitators because you've got the recovery boilers that are pretty challenging, and then you've got bark boilers, and so it's some pretty tough applications for precipitators, are they not?
Well, from a loading standpoint, yes, that's always the challenge is getting the amount of salt cake out of the precipitator that's going to come through it. So yeah, they're notorious for having high loading, if you will. That's the issue that you face. And of course, you've got lime kiln precipitators as well that offer another set of challenges too. So the precipitators in a paper mill aren't as big perhaps as they are in a coal-fired plant, but they have a number of special challenges that go with them.
That would be my understanding as well. Paul, give us a little bit of information about KraftPowercon.
Kraft Powercon. So Kraft Powercon's the world leader really in electrostatic precipitators power supplies. We have over 15,000 TR sets installed worldwide and been doing them since 1955. It's a Swedish company. The headquarters is in Gothenburg, Sweden. And primarily in the past, they've supplied to OEMs, been a direct OEM supplier. Probably in the rest of the world other than the US. There's a lot of TR sets and controls from Kraft Powercon in the US that were supplied through various OEMs through the years. About 10, 15 years ago, it's a family-owned business, and the new life has been brought into the company, and they've been doing advancement in marketing for end users and OEMs and globally. So they started the U.S. office here a few years ago, and then they acquired my consulting company, Pollution Control Services, and April 1st, 2017 was the official date, and we've set up our Pensacola, Florida office. So we provide all sales and configuration and project management and spare parts and service, and all that comes out of Pensacola, Florida. And we're servicing Canada, the U.S., and we're also part of our region is South America, Central America, and Mexico. And we're looking at setting up facilities in Sao Paulo, Brazil, and also Santiago, Chile. And we already have operations in Mexico, where we have a sales engineer in Mexico as well. Kraft Powercon, we have 4 different divisions, and so we're mainly going to talk about our high voltage division, but we'd like to say that we're a global company, a global organization. You have national organizations or international organizations, and a lot of those are independent divisions throughout the world that operate independently. Kraft Powercon's a little different to where we're global. We're all one team throughout the world. So with some of the larger OEMs that are international, this provides a much better level of customer service because we can provide seamless projects, across multiple continents.
It
So
also
that
provides knowledge too. You were telling me that you have one innovation that's being proven now in India, so that that knowledge will be usable in the United States and the Americas as you complete it.
Oh, absolutely. So we have our product announcement that our new product that has become commercially available this summer. And so we have a large installation, 48 of the units. It's multi-pulse. It's the next level of precipitator power supplies, where it provides higher precipitator efficiency, collection efficiency, at a much lower power, and also offsets a lot of the problems with back corona and high resistivity. But we have a large installation, 48 units, at a coal-fired power plant in India, and we plan to do extensive testing there. And all that data will be seamlessly, shared with the entire global group. We're all connected online, and we have, daily chats and texting on our phones. It's amazing, the technology today.
Yeah.
But, and then that product announcement, after, we're going to wait for the data to prove our technology, and then we're going to announce that product in North America, first quarter of 2020. Yeah.
And then one other point I did want to pursue with you is the merger of the two companies and the fact that you were in the consulting services. Is it not a great advantage to understand the workings of the power plant, or in Dan's case of a pulp mill, and therefore you're able to apply your products with that knowledge of the process?
Yes, absolutely. So Kraft Powercon is more of a solution provider. We just don't have an inventory of parts in our factory that you can just order off the shelf. We're more about applying our products, because anyone that's in these industries, pulp and paper or sugar mills or power plants, there's no two sites alike, and there's no two precipitators alike. And you look at precipitators through the years, there's been countless variations of companies involved, and rebuilds and upgrades and modifications, and different companies have come and went. And so coming from the consulting business and understanding intimately how precipitators work and operate, and when a power supply can give them benefit and when it can't, when it's better to apply some mechanical improvements. Having that experience and background brings lots of value to Kraft Powercon, which is a solutions provider.
And you're providing that advice to end users, but also to the OEMs that you're working with as well.
Oh, yes. Yeah. And the OEMs have another level of engineering with them, because they are precipitator experts as well. But, they're looking at a whole precipitator, and a lot of times it's nice for them to have a resource that can just handle the power supply. A lot of this engineering staff isn't what it was 25 years ago, so you have less engineers doing more work. And when you have a resource from your vendor that can provide, quick service with quick AutoCAD drawings and good, like on a direct replacement TR set, you have to change the design of the TR set for it to get to fit easily. And these are services we provide, and that helps the OEM as well. And we also guarantee our work. So, we take on that liability.
I think so. From being a paper mill guy trying to make production happen every day, having somebody that can come in and provide something that fits, and something that will start and work when the button is pressed, without having to be too involved as an engineer in the paper mill, or having, to solve various problems. Having someone to come in and provide a solution that fits and turns on and works is really the thing that keeps the paper mill going.
Right. I think that is an invaluable service. And as you say, with a lot of people retiring and everything getting so much more complex, I mean, no engineer can keep up with all the technologies, but he's supposed to know with this avalanche of information. Well, let's move along now and talk a little bit about the products and solutions.
Okay. Yeah, so if you flip to the next slide, so here's, basically a precipitator. Most of the listeners, I think, are familiar with this. You have a high voltage power supply on top and some wrappers, and you got flue gas that's entering the precipitator, which is laden with particulate. You got collection plates and some high voltage discharge electrodes, and the idea is smoke comes in and clean air comes out. So the power supplies is typically a critical part of that. The better power you can put into the precipitator, the more efficient it is. And products have evolved. And the next few slides, I'm going to go through the different products more in a technical sense, really. I think a lot of people are familiar with this, but, when do you go from one to the other? So our Kraft Classic TR sets, these have been around since 1955. I mean, this has been the staple for electrostatic precipitators for many years. They work very well. You put them in and you forgot about them. And TR sets are designed for 20-year life, and a lot of them have been running 40+ years. They've been a fantastic thing. So, but as precipitator efficiencies need to increase, power supplies need to do this as well. So, with the single phase, you have a high voltage ripple, 40–50%. So if you look at that top waveform, the voltage, if you have a peak voltage of 100 kV, you have a minimum voltage below 60. So that's a lot of efficiency loss. If you go to the next slide, we have so here's your, high voltage ripple, 40–50%. Average voltage. So now our Kraft Classic 3-phase TR set. This took the same reliability that we had in our single phase and tried to get closer to a true DC. And we achieved this very closely. You have a ripple of like 1 to 2%. So it's basically a flat line. Still has a separate control cabinet because it's 3-phase instead of 1-phase. It's larger. It's larger by weight and overall size, physical dimension.
Sure. Yep.
But it carries the single phase reliability. It's exactly the same. Instead of 1 rectifier bridge, it's got 3 rectifier bridges, but it's the same bridge. So this has been a good product. If you can move to the next slide, we have an SMPS. The SMPS has a true flatline DC, and it runs at a much higher frequency, and it's a small, compact unit. And this has become very popular through the years because it's very inexpensive to install. It's 1 unit, it goes up on the roof, it's smaller than even a single-phase TR set, and there is no separate control cabinet. There's been some reliability concerns over the last many years with SMPS technology, and how that technology is applied from other applications to a precipitator industrial application has been a challenge. And I believe we've countered that, and I'll get into that further on in this presentation. If you go to the next slide.
Well, I'll just say, you basically, when I came to industry in 1990, every power supply was a single phase transformer rectifier. So that's what you saw on some of the previous slides. And as evolutions happened and performance mandates from EPA came down and performance needed to increase, the technology increased with those demands. And that's what you saw there on those first 3 slides, was ever improving performance.
So we also have a micropulse, and this was the new product that has become commercially available this last summer, that we have some large commercial installations, and we'll be testing this product. But everyone has seen benefits of intermittent energization with the single phase TRs and also the SMPSs and the 3-phase TRs. This takes that concept to the next level, and it gives a very quick pulse of very high voltage, and so it builds a very strong electrical field, which migrates the particulates to the plate without all the counter effects of that current going through the ash layer on the plate. So especially when you have high resistivity cases or you have aggressive electrodes with some buildup on the plates, this provides very high efficiency at very low current and very low input power. So the next slide has a quick comparison of the three. The MP is kind of a different product, but this was always a good slide to compare to three. And if you look at our brochures, this is in it. And so it really depends on the application. If you just need the precipitator to run, like on some of these combo boilers in a paper mill, pretty much for the flue gas that it's conditioning, the footprint's usually larger than what's really needed. So you necessarily don't need to upgrade to a higher performance TR set. So you can just go to the single phase TR. It's the least expensive and it's been around the longest, is the most proven. And then the three phase versus high frequency, you have to find that balance between performance, or you get the performance out of both, but really cost and what you get for that. The three phase has the separate control cabinet, the SMPS does not. However, the SMPS it's not a complicated piece of equipment, but it's complex. It's complex to work on. For an example, the single phase of three phase TR set units, 2 a.m. and your shift electrician just got called to go look at the precipitator because there's a problem. He changes the controller and the SCR on the firing board and the control cabinet, and he fixed 90% of the problems that would be with that TR control cabinet in 30 minutes, and he goes home. The high frequency power supply is a little bit more advanced and takes a little bit more troubleshooting, and it's just not a couple boards that fix 95% of the problems, and sometimes replace some of the components take longer. So these are things to consider depending on the amount of resources you have to maintain the precipitator.
Yeah, this is what happened in my experience. When I came to industry, every power supply on the precipitator, all the precipitators that we had, and everyone else's in 1990, was a single phase transformer rectifier. They were, like Paul says, easy to work on. What did break was easy to diagnose, and the parts were available and something that a shift electrician could do on Friday night to keep the precipitator performing as it should be. And demands went up, and for us in the paper mill, we faced maximum achievable control technology. So we had an existing precipitator on an existing boiler, and it had to perform better. So we had to move to the right on this page here. We had to move away from the variable waveform of the single phase TR towards something that was flatter and more DC-like, like you see on the two on the right. And quite often, in the early available units were typically high frequency switch mode power supplies. So we moved from something that was simple on the left side of the page to something more complex, difficult, and initially, in the initial phases of using these devices, much less reliable. But that has changed over the years, and those high frequency switch mode power supplies are more reliable now. But you'll find in the field these days, there are a number of precipitators that still utilize the single phase TR, and you'll find, speaking with Southern Company, half their units are single phase TRs, roughly half of their units are high frequency switch mode power supplies. So at some point they had to move from the left side of the page to the right, and this is a diagrams of our offerings. We offer the single phase, we offer the three phase, we offer the switch mode power supply. We do tell people, and this is based on Paul and our experience, that sometimes we can get the same performance with that three phase TR that we can with a switch mode power supply And do it a little simpler. So
Yeah.
a little easier to work on.
It kind of comes down to a cost approach, because it's just the high frequency power supplies are less expensive, substantially less expensive to install. But now Kraft Powercon actually was one of the first with this technology in the 80s. Us, and we also worked with Flack, Alstom, in developing the SMPS technology in the 80s. But Kraft Powercon was having a difficult time maintaining our reliability philosophy on the SMPSs, and so we kind of abandoned that technology for a little bit and stuck with the 3-phase TR set. You know, our philosophy at Kraft Powercon is a precipitator shouldn't be worked on all the time. You know, you turn it on and you forget about it until the next outage. You do your maintenance and you turn it on and you forget about it. And, you know, the SMPS was a more complicated technology. If you move to the next slide, so we got back into SMPS technology with our Smartcraft product later in the late 2000s because of competition. Of course, competition's a great thing, you know, and it drives innovation, and in this case it did. So what we did is we said, okay, we're taking an SMPS technology that's being used in a lot of other industries very successfully. However, when you apply it to a precipitator where we have a lot of grounding issues and things of that sort, there's been some issues with that technology. And so we said we have to innovate a new product that's SMPS that is designed for a precipitator and just not transferred over from another industry. And some of the problems on a precipitator roof is temperature. So we're oil cooled. Most of our competitors are air cooled, or the other equipment that's out on the market. We have 12 IGBTs instead of 4 to 6 IGBTs. We have an aluminum tank, which helps us shield quite a bit when you come to this high frequency, and also harmonics off that high frequency. Most of the others are using a steel tank. The key item is we have a phase shift resonance converter. That's a big, long technical term, so basically say an amplitude control. All the others on the market are using a frequency control. So basically a frequency control, they just vary the width, and what current conducts, it conducts, and it's difficult to turn off. So on very high current spikes, say in sparking, where you have poor grounding because it could spark anywhere in that precipitator, you could have some very high transient voltages getting back into the control cabinets and causing failures. In our technology, we're using an amplitude control, so we are actually controlling current. So current can never inrush or go to extreme values. And if there's an issue, we turn the current off. So once you turn the current off, there is no high transient spike going back into the system. And so these are some of the things where we said, you know what, we have to innovate, advance beyond what's already on the market, because there are some reliability concerns. And reliability has gotten much better. I don't want to compare reliability today of what it was in the 90s.
Right.
However, you know, we do need to get to the point, and we do that with our Smartcraft. You turn it on, you walk away, and you come back a year later during your outage, and just, you know, you need to do a little bit of maintenance on the Smartcraft, keep our radiator clean, things of that sort. So if you go to the next slide, this talks a little bit about our phase shift versus the frequency control. And as you can see, you know, this is at full load. You can see the current, you know, where both of these are 1,000 milliamps, but ours is more of a uniform, and our competitors are having much higher spikes.
Yeah.
And we get this technology because we also have a whole nother division that's high current. So that's where we applied the technology. And so the next slide kind of gets into turn down abilities as well. And as you start to turn down with the phase shift, you can see the changes in current. And with ours, you know, you can see where it's more uniform. I think we're getting a little bit too technical.
Well, there's the amplitude. Yeah, there's the picture of the amplitude versus frequency control that he mentioned earlier. If you on the Smartcraft side, the current curve is growing in size from the top to the bottom, and in the competitor, section on the right, the spikes are roughly the same size, but the frequency is changing. So that's just a demonstration of what's going on in our amplitude control that we do versus the frequency control that's done by our competitors.
So next slide. You know, and we have various, you know, now we get into safety where we have our different switches on our TR sets. And, you know, of course, a ground switch is needed to ground the precipitator. And most of this design is for personnel protection. And so we have, you know, an internal ground switch. What's nice about the Kraft Powercon TR set is we have a sight glass that you can actually see the positive contact of that switch. Many TR sets that are out there with the internal switches don't have that sight glass, so it's really a guess if it's grounded or not, which you know, which doesn't really give a full safety. It doesn't bring the potential to zero. So, and then you go to the next slide. We have external ground switches. I think anyone that's experienced in maintenance of precipitators would very much appreciate our ground switch. It's basically been the same design for decades. The parts, the switches, and the different individual pieces of our switch are the same for decades. So if a switch does have an issue, it's easy to get replacement parts, but it's a nice one solid stainless steel handle that closes and opens reliably time and time again. You know, we demo our product quite often. We have this switch on display at trade shows. We welcome you to come to our booth and look at it. I think you'll be very impressed with our switch design. The next slide. This is if you have combustibles in the gas stream. This is very important. And also you see this in oil refineries where unfortunately you've had some explosions in precipitators. What happens is you have a TR set that's providing high voltage that's being driven to a spark. So that's ignition. You get high combustibles in the precipitator, you have ignition, you have an explosion. What the process is in many of these facilities is they know that combustibles may be getting to the precipitator, and all they do is they turn off the power to the controller. The difficulty is there's still a static charge within the precipitator.
It's a giant capacitor.
Right.
Yes.
It's a giant capacitor, and the density of the gas may change to where now the spark level may lower. So as the combustibles enter the precipitator, there's still potential for a spark. It sparks, and we have an explosion. What this ground switch does is, if there's a potential for combustibles in the precipitator, this ground switch is notified. It disconnects the TR set physically with an air gap and grounds the precipitator field within 1 second.
Discharging the capacitor, so the ignition source is no longer there.
The potential goes to zero. So this is a good product that we're proud of, and again, it follows the same design as our other ground switches, and so it's reliable, it's easy to get replacement parts, and you know, they just don't fail over time. It's a very positive contact type switches. And again, we have this on display. Come to any of our shows that we're exhibiting at. We'd love to demonstrate it for you. Next slide. Control. So, you know, this is our latest. What was the previous slide? Did I get ahead of myself? No, okay, you're right. I'm sorry. So the next slide. You know, TR controllers are TR controllers are TR controllers. I'd love to tell you that we just created a new mousetrap or a different way to slice bread with our controller, but the algorithm of TR controller has been around for 30, 40 years and it works well. Our new controller is nice because it has a touchscreen digital display. It has onboard graphics for scope readings and trending. And a key thing is what comes standard with all our controls that doesn't require additional purchase of equipment is Modbus or Ethernet TCP/IP. So this is a 2019 product that can seamlessly be integrated into complete plant systems.
I think they did a good job using the capabilities of the new LCD screens, which is, you know, so you no longer have a 4 or 5 line text display. You now have a graphic. And if you've ever seen a transformer rectifier before, you'll recognize the graphic and you'll recognize how to turn it on. So it's to use a overused word, it's real intuitive to someone who's seen one of these devices before. The graphics are well designed, so it'll be familiar to operators. And then for what I like about it is having been a person who had to bring data across separate systems into, say, a DCS or a PLC, that Modbus capability or Ethernet capability or a number of flavors communication protocol can make life easy on the person who has to make these functions show up in the mills or the plant's computer control system. So it's got a lot of flexibility that should go along with this generation of controllers.
And what I like about it too, that's nice, proving that we're global, is you go into configuration, which is a quick password to get into it, and it automatically, you can change it to 20 different languages, I think we're up to. And as we find new applications or go to different areas, we upgrade the language. So, and this is nice out of our Pensacola office because we have 3 languages we're supplying to. We have potentially 4 French with French Canadian, but you got US, which is English, Mexico, Central America, and some of South America is all Spanish, and Brazil is Portuguese. So, our standard controller, we can easily change those languages in it, and the customers in South America are really liking that feature. So on our next slide, we've been doing controllers for a long time, and they're all upward compatible. So what we just want to show here, if you have or you come across one of our older controllers, it's basically a plug and play. Customers will still hire our service team to do the installation, and then they're embarrassed when we show up and we do each one in 30 minutes. But most of our customers are upgrading these on their own. We're available for a phone call when they have those questions. But it's basically plug and play. You pull out the old controller, put the new controller in, plug it in. All the configuration, all the settings, all that is done in the factory. That's another thing we pride ourselves on at Kraft Powercon. You're buying a system from us, you're buying a solution. So to have to go through all the configuration and settings and commissioning, why do that? When you get a controller from us, even the spare part controller has all the configuration, all the settings, all the calibrations is all factory done. There's nothing you need to do but hit the on button. We can't turn the high voltage on. You need to do that part.
Well, we have a lot of customers, that have bought from OEMs, and we get a lot of calls about upgrading from the MK2, and we provide a pathway to integrate the older cabinets from MK2 to MK4, and that seems to be our most popular upgrade conversion right now, because we no longer can support the MK2 product. It's been out of production for a number of years now. So we need our customers, like other people do, to other OEMs do, to come along and upgrade to something that we can support a little better. But it's been easy. We've had a number of customers who've done the MK2 to MK4 conversions themselves.
Next slide. This talks about the conversion as well. MK2 to MK3 to MK4. Seamless upgrades. Next slide. So control cabinets. This is pretty standard, but this is a picture of complete control set cabinet. We also, for the tumbling hammer systems, we also handle that in the same cabinet as the AVC controller. So there's no need for a separate wrapper control. We have various enclosure ratings from our standard, which is designed for a control room like an MCC room, to outdoor applications as well, NEMA 4 and Vortex coolers and things of that sort. Next slide. This is our communication system, NetCraft is what we call it, and the basic communication comes with the controller. So there's not an additional interface you need to purchase to be able to do that. So you can immediately just, you know, plug in your Cat 6 cable and you're done. You can remote access from anywhere in the world if we can figure out a way to get past cybersecurity concerns. But the main thing is anywhere within that plant, any computer in that plant. And if they have Wi-Fi and your phone's connected to it, you can also connect through it through your cell phone. You know, I don't know if people have seen us come give demonstrations, but it was always interesting when I pull out the iPhone in my pocket and I start controlling our demo controller with it. You know, and then we also have, go to the next slide, I think it talks about our, you know, we also have the separate precipitator management system. And this is through customer demand. Our philosophy is our system should be tied into the main DCS system and your PI system for archiving and trending, because the precipitator is on the back end of a whole nother process. And, you know, coal starts from a conveyor and goes into the boiler, gets combusted, comes out of the boiler, goes through an air heater, goes through an SCR sometimes, you know, the precipitator, scrub house, you know, all that needs to be looked at in a holistic approach. However, people still want the separate ESP management system, in which we provide that as well. And what's nice about our system is it can easily be connected to with any computer on the network. You know, it don't have to be our proprietary computer, although we provide that as well. You know, what's nice about it being provided on our computer is it's completely tested, configured, and set up at the factory prior to shipping. Next slide. So this was, you know, some of our direct replacement retrofits. I noticed our logo's messed up there, but that's okay.
Sorry about that.
Yeah, sorry about that. But this was a GE designed TR sets. They've operated very well. I think this precipitator is 40 years old or greater. The difficulty with the GEs is, you know, this is a lodge control precipitator. You know, as you can see where they have the penthouse next to it, and you have the bus duct that connects through the side wall. There is no replacement. GE doesn't make these TRs anymore. I heard there's some sources out there, but they can be expensive. But so we're able to do a custom. It's easy for us to do custom design on our TR sets, and basically all we do is move things around on the TR set and still comply with our ISO 9001 quality control procedures as well. And so here we're able to put the junction box, have the conduit connections in the same place using the same cable, which is important. When you start talking 500 MCM cable, that stuff is difficult to work with. So if you don't have to cut it, re-terminate it, or change it, that's a big benefit. This slid directly into the side wall, and instead of an internal ground switch, it's got an external ground switch. So the plant maintenance did this themselves as simply as they did with a spare TR set from GE.
Well, this is where we talked earlier about, and you mentioned, and thank you for doing so. We're engineers and we're old guys and we've been around a little while. So this is what you face as a precipitator owner. On the left picture, you'll notice two round TRs, and at the bottom of each one of those TRs, there's an oil pig, what we used to call an oil pig. So this is what everyone faces. Eventually, the oil that's on the inside of the transformer rectifier is now on the outside. Well, specification calls for the oil to be on the inside. So you've got a safety issue of leaking oil. You've got a potential failure there if the oil leaks too low, or you let that oil leak happen for too long. So now you've got an issue in the plant that you need to face. You have a round TR that hasn't been made in a number of years, connected to a rather odd bus duct system at the top. And this is what we've done for this customer, and we'll do practically or try to make it practical for all customers, is to create an opportunity to put in a new TR like you see on the right and make it fit, make it easy. And like Paul said, this was done by this plant, AEP Oakland Union. Was able to take our brand new TR, take out the old TR from what, 1980, 80, 81, 82, and put in a new, and keep this precipitator functioning, because we were mindful of the dimensions, not only of the bus duct, how it fit to the bus duct, but we were also mindful of the dimensions of how the incoming power wires connected to the TR. So you'll notice none of the conduit had to necessarily be cut significantly to cause an issue. And the power supply fit up. The customer was able to do this on an outage, and we were able to make it fit so that he could do it as inexpensively and easily as possible.
And what's nice is now the customer has a brand new TR set that will, you know, it's designed for 20 years, but they'll probably get 40. Plus, we haven't hit a big part of our business has been this direct replacement of TR sets, because the average age of the TR set out there in North America is over 40 years old. And it's been the same price. So there isn't been inflated cost of our TR set. It's the same TR set, same pricing. Next slide. And same thing on retrofit cabinets. So this is the same site. You know, it had an old controller in there. The old controller was great when it was put in new in the early 90s. You know, yep. So you know, and we were able to put in a new controller. And this is our MK4. You know, so the retrofits are pretty clean and easy to install, and we do that as well. Next slide. And here's some case studies that we can go through. You know, we got, if you call us, we have, you know, I got a whole stack of these. So, you know, to go through hundreds of these, I don't think we probably already bored you a little bit too much. But, you know, so I just picked 4, and these are varies in size. And you know, on the left side is kind of information about the plant and before the retrofit. And on the right side is what we did with the upgrade. You know, this was a biomass unit, had 2 single phase TR sets and control cabinets. And we put in Smartcraft, our SMPS, on both things. In this particular case, there was also some upgrades. I'll acknowledge that as well. But they had a big jump in performance, 300 milligrams per normal cubic meter down to 27. To put this in perspective, this was, like, 0.08, 0.09 pounds per million BTU, and now they're below 0.015. Next slide.
It's compliance.
This is another, now this is a larger coal-fired power plant in China, 500 megawatts. As you can see, the precipitator is, so to say this lightly, in China and in other markets of the world, you'll have different tiers of TR sets. So, in India and China, and this is just the fact of reality. So I don't want to get into competitors and things like that, but you have 2 tiers of suppliers in both these areas. And you have the one tier where, the TR is just good enough. They put it on, it puts high voltage in the field. It really doesn't need to have to actually meet the limits and the ratings of the TR set. It just needs to put some voltage and allow some current to go into the field, and reliability isn't all that big of a concern because they just put it on and they operate it. Well, laws are changing in China, already changed in China, and they are getting ready to change in India to where it'll be more closer to the US. That it used to be they just paid a small nominal fine if they exceeded their emissions. Now they actually have to continue to derate the unit until their stack emissions are in line. So they needed to upgrade with their units. So here we replaced the local made switch mode power supplies with our Smartcraft switch mode power supplies in just the 2 inlet fields. And what I want to highlight here is the power of having good performance in your inlet fields. That's all we did. They had a 39.4 milligrams per normal cubic meter, which was above their limit. So they were taking D rates. This would be like, operating at, 0.04 or 0.05 pounds per million BTU. The target was 20 milligrams per normal cubic meter, and we were able to do that. just by putting in a tier 2 power supply, that's what Kraft Powercon offers. Which gave them the reliability, and when we wanted 80 kV, 1600 milliamps, it produced that. Next slide. Another case study. This is a coal-fired power plant, a smaller one, 70 megawatts. We did some normal maintenance of the precipitator, nothing great. But we basically changed the inlet fields from a single phase TR set to an SMPS. And they were running 50 milligrams per normal cubic meter, needed to drive that down under 40, and we were able to get it to 25 so that gave them a little bit of margin. Another successful project highlighting, you don't necessarily need to upgrade all your fields. You can just do a couple fields. Next slide. I think we have one more here. We do. This is actually a cement plant in India, clinker cooler. Not many cement plants that still have precipitators. Most of them gone to bag houses, but there's some out there. And this is where we changed a single phase TR to 3-phase TR. We also did correct some mechanical damages that were in the precipitator. And this was also where, our precipitator knowledge helped, because we had our consultant go in and do the inspection and write the punch list for the customer to correct. So this is where we're more of a solutions provider. The customer came to us with a problem and says, how can we fix this problem? And we says, well, we need to do some key repairs to your precipitator and go from single phase to 3-phase. And here again, we had a pretty good result, 65 milligrams per normal cubic meter, which was above their limit. And we drove it down below their target, so they have some operating margin as time goes on.
Well, there's actually one more case study after this one. And,
oh, I'm sorry. Okay.
And it does note some performance increase like you would expect. The precipitator on the left is out of compliance. The precipitator on the right came into compliance. And this application, by the way, was something I wanted to point out. The Kraft Classic 3-phase TR was installed here. The performance, and we've got some other cases that we can talk about, and we'll love to talk about. One in North America particularly, I'd like to talk about. But this also is a performance benefit. But one thing I wanted to point out is that this particular outage this was a cement kiln, reburning pet coke, but it was done in less than 3 days. So this just points to the practicality of how we try to make this easy for our customer. We made this conversion for them in a very short period of time, and we're able to plan ahead and make it where it could be done in this number of days and get this customer into a better position.
Yeah, Dan, that's a good point that a lot of people that we take for granted at Kraft Powercon, but our customers aren't accustomed to. We took on the design to make the 3-phase compatible with the single phase.
Yes.
So we minimize as much installation time as possible by matching junction boxes and reusing electrical cable and reusing bus ducts. And so we can do this in 3 days.
Well, that's what we want to say is we're a solution provider, and we're interested in not only dropping a box on your doorstep that might help you, but helping you put that box in and implement it in a way that will help you.
So I think that's all our slides.
Yeah, it's been a very, very interesting presentation. The one question I would ask of you here, in the case of China with that Long King unit being replaced there, were you working directly with the power company there, or were you working with Long King, or is that a detail that just escapes you in that it's China?
Yeah, I don't know the answer. If I did, I would be guessing, to be quite honest with you.
But you're working with either the end user or the OEM in many cases, right?
Either scenario. So it all depends. I mean, we work very well with, we have, 40-year relationships with some of the OEMs. So we're never going to go in there and compete with the OEM. If the OEM's established at that plant, absolutely we'll work with the OEM. Sometimes the customer wants to just deal with us directly, or it's just a project that the OEM's not interested in. It just falls outside of what their ideal scope of supply is. But yeah, either case.
Yeah.
Either case.
And then one last question relative to the cement plants. You have a couple cases here where you're bringing down emissions, for instance, below 17 milligrams here. And that puts the plant into compliance and may allow them to extend the life of the precipitator before they, say, replace it with a baghouse, which a lot of people seem to be doing. So as a life extension investment, would this not be a good idea in many cases, since you can reach these low emission limits?
Oh, absolutely. And it also saves a lot of cost. To replace your precipitator with a baghouse is, tens of millions of dollars, where to replace, some TR sets with high frequency power supplies is not even in the millions. It's,
Yes.
six digit US dollars.
Yeah.
So from a cost standpoint, running the precipitator to an end of its life with higher efficiency is going to be a better alternative cost-wise than putting in the baghouse.
Sure. And there's many cases where precipitators have been preserved pretty well through the years. It hadn't been attacked by corrosion and things like that, and it was a good design to begin with, and the maintenance has been kept up on it. A precipitator can last many, many, many years. Some applications, they don't last long. Other applications, they're in very good shape. So just upgrading the power supply from a precipitator that was installed, now this one was 25 years ago. You're just applying modern technology to an existing piece of equipment and getting the benefit from it.
Well, this has been a very instructive presentation by two very knowledgeable people. And fortunately, we do have it recorded. We will be providing a link to it in our utility e-alert this afternoon to the recording. And we'll be linking to it from our precipitator newsletter. And of course, Kraft Powercon will be making it available through their website and various other means. So I would like to thank Paul and Dan for a very good presentation and look forward to further discussions with them.
Thank you, Bob.
Thank you very much.